Hello students, welcome back. This is second lecture on the first chapter of NEET syllabus, which is unit, dimension and measurement. In last lecture we have learned about units, like what are the units, what type of units we have, and the questions based on units which they ask in our NEET exam, that we have done already. Okay, so in the second lecture we are talking about the next topic, which is dimensions. Okay, let's start. So first, what are the dimensions? Okay, I will not give definition. Let's understand with example directly that what are the dimensions. Okay, let's write dimension of anything which you know. Let's write a simple thing like force. When I say force, its dimensions m power 1, l power 1 and t power minus 2. If you know how to find the dimension of force, it's okay. If you don't know, just wait for few time. We will learn these things. Okay. Yes. Right now I am just explaining that what are the dimensions. Okay. Definition. Okay, look here. In this formula, force, these are dimension of force, m power 1, l power 1, t power minus 2. So what are these m, l and t? These are nothing but what? Fundamental quantities. Fundamental quantities. In last lecture we have learned what are the fundamental quantities. We have 7 fundamental quantities. So these are those only: mass, length and time. Correct? These are the fundamental quantities. Then these you can see some numbers here, powers 1, 1 and minus 2. This one and these. These powers are called dimensions. These powers are called what? Dimensions. Okay. Just wait, I will give definition. Okay. So these are the fundamental quantities and power to them are called what? Dimensions. This is a group. When you talk this whole group, like MLT, all this together with power, this is called a dimensional formula. This is called a dimensional formula. Okay. Or you include the other side also, like you say force and this side, then this is called a dimensional equation. Right. 4 terms I just spoken to you. MLT. These things are called fundamental quantities. Yes, we learned, and total we have 7 fundamental quantities we know. So all this dimensional formula that we learn in this chapter will be expressed in terms of these just 7 fundamental quantities. And when I say this group is called a dimensional formula and include both sides, that's called a dimensional equation, right? Okay. Then we are talking about dimension. What's the definition of dimension? I said these powers like 1, 1, minus 2, these are called dimensions. So how we define dimensions? These are the power raised to, these are the power raised to what? Fundamental quantities. I write it here. Fundamental quantities in order to express a derived quantity. Let me explain you once more. Definition saying that these are the power raised. These are the powers. Yes, these are power raised to what? Fundamental quantities. Yes, these are fundamental to express a derived quantity. Derived means combination of fundamental. Yes, this whole thing is this thing we talk. This is a derived thing, right? Derived quantity or derived units also we have. Yes. So this is simple definition of dimensions. These powers are called what? Dimensions. Suppose 1, 1 and minus 2. These are the dimensions of what? Your force, right? Same way we learned how to find dimension of all the things that comes in physics. We have infinite number of things whose dimensions we have to find. It's very easy to find. We will learn some rules. By using them, we can find dimension of anything. Okay. Okay. Let's talk about those rules. How to find dimensions. Okay. So we're talking rules to what? Find dimensions. Okay. We have just 2 rules, and using these we can find dimension of anything that comes in our physics. Okay. Rule number 1 we talking. Rule number 1 says that all mathematical functions have 0 dimensions. 0 dimensions. Right? All mathematical functions has what? 0 dimension. Now what's the meaning of this? Let's understand. First understand what are the mathematical functions. For example, we are talking about mathematical functions like all logarithmic functions like log x, all exponential function e power x, all trigonometric functions sin theta, cos theta, all these, okay, whatever, we have all 6. Then numbers like 1, 2, 3, all these numbers, you can have negative number also, or some constants like pi, okay, these all are what? Mathematical, or like we have integration, differentiation, all these things. So these all mathematical functions, they should have what? 0 dimensions. And what's the meaning of 0 dimension? We will understand with help of examples, okay? Yes. So let's talk how they ask an exam questions on what? This rule, okay? And how we use this rule to answer some questions or to find dimension of what? Some unknown quantities, okay? Okay, suppose I give some questions to you. They said something formula will be given to you. Say y is equal to log of k x square by v. This is given to you, and they will explain all the quantities that comes in this formula. They will say like y is the displacement. Okay, here I write, I can write something else because I wrote displacement here also. Let's write here force. So I can write x is the displacement, say F is the force, and V is the velocity, and K is the unknown whose dimensions you have to calculate. They will ask you to calculate dimension of this K quantity, okay? Yes. So some formula is given. This formula may be known to you, which comes in our like 11th and 12th class syllabus, or it may be unknown, doesn't matter, okay? Yes. Now we have to find the dimension of what? This K thing which is unknown to us. So what the rule says, all mathematical functions have 0 dimension, right? It means what? This is a mathematical function log or exponential, anything could be given. This term that coming with this mathematical function, this should have 0 dimensions. So what we do, we pick the whole thing and write it here, kx square by v, correct? This should have 0 dimension, means it should be m power 0, l power 0, t power 0. In 99% we will talk about these 3 basic fundamental whose dimension we will calculate. Then other things will also come, like current will come, temperature will come, these things will come, okay, later. Okay, these people has, that term has 0 dimension because of mathematical functions. So m power 0, l power 0, or we know that someone's power 0 put means answer is what? 1, correct? Numerically is equal to what? 1. Dimension is 0, numerical value is what? 1. So what you do, just we rearrange this formula, we have to find k. So k will be equal to v by what? X square. Now we have to put the dimension of these known things and we can calculate unknown. So velocity means L power 1, T power minus 1 we know, and X means what? Displacement, so it's become L square. So dimension of K will be L power minus 1 and T power minus 1. Thus your dimension of the K unknown. Correct. So what I am saying, with any mathematical function, it could be logarithmic, exponential or trigonometric functions, the whole term that coming with that mathematical function, it should have what? 0 dimension. Or 0 dimension means m power 0, l power 0, t power means its value is equal to what? Simply 1. So you write the whole term in front of you is equal to 1, rearrange this and put the known dimensions and find the unknown dimension, right? Okay, let's understand with some more example. Okay, let's do some more problem to understand this rule. Let's write something alpha is given by v square by beta e power minus beta x square by v. Suppose this is given to you and they are asking you to find dimension of alpha and beta. The other terms they will explain. Here v is the velocity and x is the displacement, and alpha and beta, these dimensions you have to calculate in this term, okay? Yes. So same procedure you have to follow. This is what your mathematical function, exponential function, right? So everything that coming with this whole term should have what? 0 dimension. Let's pick that. So that term is coming with that exponential function, beta x square by v. This is complete dimension should be equal to n0, l0, t0 or equal to what? 1, right? The complete term with the mathematical function we have picked it and equated to what? 0 dimension or equal to what? 1. Let's rearrange this. Beta should be equal to v by what? X square. Velocity dimension we know, let's put it here, and displacement dimension also we know, So the answer becomes L power minus 1 T power minus 1. This is the dimension of what your beta. Now we understood that this is a mathematical function. This whole term has dimension equal to what? 1. Sorry, dimension equal to 0, numerical is equal to what? 1. So now this remaining term, the alpha is equal to what? V square by beta. Let's pick that. So alpha is equal to what? V square by beta. We have to find alpha. We know dimension of velocity is L power 1 T power minus 1, and square is there. So L power 2 T power minus 2. Beta we have calculated already here. L power minus 1 T power minus 1. So this answer become L power 3 and T power what? Minus 1. This is the dimension of what? Alpha. Right? Two things are unknown here. Both you have found. First you use mathematical function is given here. So you pick this term and equate it to 0 dimension. We find the dimension of what? Unknown thing, beta. Then this term has 0 dimension. So this simply equal to what? That term. That we equated here and found the dimension of what? Alpha. Right? Okay. Let's do one more example to clear this thing. Okay. Suppose something is given to you and I gave example in terms of exponential function. Let me give logarithmic already I gave. Let's write some trigonometric function. Suppose some formula f is equal to write a b square cos b t square. Write this like this one. Okay, this is given to you. And they will explain the meaning of these terms which are coming here. F is what? Force, and T is the time here. We have to calculate dimension of what? A and what? B. These dimensions we have to calculate. Okay. Yes. So same rule we have to follow. Let's first look at mathematical part. This is a mathematical function cos theta. So anything coming with that should have what? 0 dimension. This whole term we pick. We say that beta into t square should be equal to m0, l0, t0 or equal to what? 1. Okay. We have to find beta. Beta is equal to what? 1 by t square. So 1 by t power 2. Answer become t power minus 2. This is what your beta dimension. Now this term has 0 dimension complete. Means that should be equal to what? That. So again same way we pick it. F is equal to what? A upon what? B square. We have to find A. A is nothing. F into b square. So force dimension we know m power 1, l power 1, t power minus 2. B square already we calculated. So t power minus 2 and we square we need. So it become t power minus 4. So the final answer of A will be m power 1, l power 1 and t power minus 6. This is the dimension of what? A. That's the dimension of B. Okay, we are talking about how to answer the dimensions in what? Like integration and what? Differentiation type of questions. Let's understand them. Suppose I ask you dx by dt. What is the answer of this? Okay, it's very simple. You don't need to worry. You can confuse with that rule as I said that all mathematical function has 0 dimensions. So you should be careful here. Dx by dt. We are talking about displacement and time. So what is the answer of this? Simply displacement L power 1 and time power t power 1. Answer become L power 1 t power minus 1. Also know that differentiation of displacement gives velocity. Yes, this is the dimension of what? Velocity. Correct. Or let's see more example. If I say like m into d2x by dt square, what is the answer of this? Same rule. M is mass, m power 1 is a differentiation of what? Displacement, right? But be careful here is dt square by into x. So x is coming, x power is what? Only 1. So you write here L power 1 alone. But down is become dt square, time square is coming. So you write t power what? 2. It's very important. Here differentiation, double differentiation we know, yes, but it's d square into x. So x power is what? Only 1. But down is dt square, time square coming. So I wrote power t power 2. Okay. So answer of this comes m power 1, l power 1, t power no. Yes, this is a dimension of force we know, because this is nothing but what? Acceleration. Double differentiation of displacement gives what? Acceleration. M into a is what? Force only, right? Yes. Okay. Like these are example of differentiation. Let's talk about integration. Suppose I say what is a into dt, where this a is acceleration. If you confuse, acceleration I am talking. Okay, what is integration of acceleration into dt? So what is the answer? Acceleration we know is what? L power 1 t power minus 2 meter per second square we know unit. So dimension become L power 1 t power minus 2. into time. Dt means what? Into time. So this answer becomes what? L power 1 t power minus 1. Yes, you know the acceleration into time is called what? Velocity. This is dimension of actually what? Velocity, we know, right? Yes. Okay. Let's do like one more example. Suppose I say what is the integration of v into what dt? This is what I am talking about, is velocity. So already you know that velocity in time is called what? Displacement. So what should be dimension? Velocity means L power 1 t power minus 1 and dt means what? T power 1. Answer becomes what? L power 1, which is what? Nothing but displacement. Yes, already calculated. So these are what? Like integration and what? Differentiation type of, if they are asking dimensions to you. Correct? Okay. So now what we will do? We move to our rule number 2. We have learned rule number 1, which says that all mathematical functions have what? 0 dimensions. Okay. And how they ask in question exam? We have discussed this example with you. Okay. Let's talk about second rule. Rule number 2 is even also more important than rule number 1, because maximum time we have to use this rule. Okay. This rule says that two or more quantities which have same dimensions can be added or subtracted. Okay. Rule number 2 says that if you are adding two quantities in physics in any formula and equations or subtracting them, it means what? They have what? Exactly same dimensions. Or opposite, if two things have same dimensions, then only you can them add or subtract in a formula or an equation, right? Okay. By definition you may not understand, so let's take an example to understand this. What I am trying to say is this. Let's pick any equations or formula of physics. Let's say our equation of motion. S is equal to ut plus half at square. Now understand this rule. Here we see that we have three quantities, 1, 2, and these are three terms we have. Okay. Yes. So rule there says that because they are added, like these two terms are added, or we can subtract from s minus ut plus half at square, they added or what? Subtracted. These three terms are added or subtracted. It means what? These three terms should have exactly same dimension, then only we can add them, right? Okay. Let's check whether they have same dimension or not. Okay. This is a displacement. What's displacement is what? L power 1, length simply, right? This is a velocity into time. So what is dimension? Velocity means what? L power 1 t power minus 1 and time is what? T power 1. This t power minus 1 plus 1 get cancelled. Answer we getting here L power what? 1 only. Correct? Yeah, this also has L power 1. This also has what? L power 1 dimension. Let's check about this. Okay. Half is a mathematical thing, right? Mathematical constant. So it should not have any dimension. Dimension of half is what? 0. Acceleration. Acceleration dimension is what? L power 1 and t power minus 2. Okay, and time power what? 2 given. This again get cancelled. Again we getting answer here as what? L power 1. So you show that this term has dimension of L power 1. This whole term also has L power 1. This term also has dimension of what? L power 1. Everybody has what? Same dimensions. This is a rule that if two things are added or subtracted means they have what? Same dimension, or opposite we can say that if you are adding two things or subtracting two things or more than two, it means they should have exactly same dimensions. Okay. Okay, you have understood the rule now. Now what's the use of this rule? Using this rule we can find any unknown dimensions. How? Suppose in the same formula anything is unknown to you. Suppose instead of time I write here something unknown k. Then I ask you that what is the dimension of k? Then what we do? You can compare any two things because everybody has same dimension all terms. So you can pick any two terms, compare them and find the unknown dimension. Okay, I know dimension of this thing. So what I do? I pick this term as its dimension should be equal to what? U and k term. Dimension of these two terms should be equal, or you can equate this is equal to that, that is equal to that, whatever you want you can do because every term has what? Same dimensions, right? Okay, I have to find k. So k is equal to what? S by what? U dimensionally. S means displacement L power 1, U means velocity, so L power 1 t power minus 1, this get cancelled, answer is coming t power 1, means this thing has a dimension of what? Time. Yes, it was time there we know, right? Because S is ut plus half at square. Hope this rule is clear to you. Okay, we'll talk some example which has been asked in exam based on this rule.